We now determine the area enclosed by the two curves and the vertical lines. The two curves are f of x equals e power x and g of x equals 1 over x. And the two lines are x equal to 1 and x equal to 2. So here I have drawn the sketch of the curves as well as the vertical lines. So this one is the f of x equal to e power x. So this is always an increasing function. So the graph increases from left to right. And then the another curve, this is g of x equals 1 over x, which is a reciprocal function. And it decreases above x-axis, and it also decreases below the x-axis. We will not consider this portion which lies below this x-axis. This is also part of the g of x equals 1 over x function, but we will consider only the portion or the curve which lies above the x-axis, so that we get the enclosed region. And we have the two lines x equal to 1 and x equal to 2. So as indicated in this diagram, the region ABCD is the enclosed region, and we have to determine the area of this region. To determine its area, we place this area between the curves formula, which says that if we have two functions f of x and g of x defined in the interval a comma b, the area bounded by these two curves and the lines are given by integral of x equal to a, and the upper limit is x equal to b, the absolute value of f of x minus g of x dx. So let's use this formula to determine this enclosed region. So I write down this area of region ABCD, and this equals, we integrate between the lines, that is the x equal to 1 and x equal to 2, and then we put this absolute value. Uh, the top curve is this f of x equal to g of e power x, minus the bottom curve. This is g of x equals 1 over x. And then we put dx. And if you are able to identify the top curve and the bottom curve, there is no need of this absolute value. But anyhow, we will use this absolute value in case if you are not sure about which curve is the top and which curve is the bottom one. So let's evaluate this integral. So therefore, this equals integral from 1 to 2. We have to integrate this e power x minus of 1 by x. That is e power x. I can consider this as two integrals. That is integral of 1 to 2 e power x minus integral of 1 to 2 1 over x dx. I have just removed this absolute value because I have clearly written the top curve, which is f of x. So I put the f of x in front minus the g of x. So we will not have to use the absolute value. Now let's evaluate this integral. So this equals integral of e power x is e power x, and this has to be evaluated between the limits 1 to 2, minus integral of 1 over x. This is, when we use the standard formula, this is natural logarithm of x. It is absolute value of x. So this has to be evaluated within the same limit, that is 1 to 2. Now let's substitute the limits. So we put the upper limit. So therefore this becomes e raised to the power of 2 minus the lower limit. When we apply the lower limit, it becomes e raised to the power of minus 1, minus we have a natural logarithm of absolute value of 2 minus natural logarithm of absolute value of 1. Let's simplify this. So this is e squared minus e power 1 is e, minus we know that the natural logarithm of 1 equals 0. So this term gets cancelled, and we simply have a natural logarithm of 2, but we have a negative in front. So it is a negative of natural logarithm of 2. We put this expression into the calculator, and we can find its decimal equivalent. That is this approximately 3.9776. So this is the area of the region between the curves and the vertical lines.